Let's do an example to see how to solve the cost minimizing choice of inputs. So let's say the Ford Motor Company can produce cars according to the following production function. So the number of cars produced as a function of labor and capital is if they use L units of labor and K units of capital, then they produce 1.52 times L to the 0.6, K to the 0.4 cars. So the exercise is to find the lowest cost of producing 100 cars when the wage rate is 24 and the capital rental rate is $8. Remember, the tangency rule says we want to set the slope of the isoquant equal to the slope of the isocost line. So let's do that. So the slope of the isoquant, remember, is the marginal rate of technical substitution, and the slope of the isocost line is minus W over R. So let's first calculate the marginal rate of technical substitution. Remember, that's just the negative ratio of the marginal products. The marginal product of labor is, remember, the production function is 1.52 times L to the 0.6 times K to the 0.4. If we want the marginal product of labor, we take the derivative of this with respect to L. So we get 0.6 times 1.52, which is a constant. The K to the 0.4 is also a constant with respect to L, times L to the 0.6 minus 1, which is negative 0.4. So if we simplify this, what we're going to do is we're going to pull out the L to the minus 1. So we get 0.6 times 1.52 L to the 0.6 K to the 0.4 times L to the minus 1. This looks a little bit familiar. It's just the total quantity. So the marginal product of labor is just 0.6 times quantity divided by L. L to the minus 1 is just 1 over L. Similarly, the marginal product of capital is going to be 0.4 times quantity divided by capital. We do the same exact exercise, except we take the derivative with respect to capital. So when we take the ratio of those two, the marginal rate of technical substitution is negative ratio of the marginal products. So get minus negative of this guy divided by this guy. The q's cancel out. So we get 0.6 divided by 0.4 times K over L. And 0.6 divided by 0.4 is 1.5. So we get minus 1.5 times K over L. That's the marginal rate of technical substitution. What we do now is set this equal to W over R. Remember, W is 24 and R is 8. That's given. So 24 divided by 8 is 3. So we're setting 1.5, negative 1.5 K over L equals negative 3. Negative signs cancel out. Divide both sides by 1.5. So K over L is 3 over 1.5, which is 2. So K equals 2 times L. Okay, so we've got one equation. We still have two variables. So what do we do next? What do we use for the next equation? Well, we're going to use the fact that our production function tells us as a function of K and L how many units we need to produce, how many units we can produce, and we know how many units we need to produce, which is 100. So remember, we wanted to produce 100 units. So production, we plug in L and K to our production function and set that equal to 100. That gives us our second equation. So we can plug in K equals 2L from the first equation to here, and that'll allow us to solve for L. So we can factor out L. So L to the 0.6, L to the 0.4, the product of those two things is just L. So we get 1.52 times 2 to the 0.4 times L equals 100. So L is just 100 divided by 1.52 times 2 to the 0.4. Plug that into your calculator and you'll get roughly 50. Let's just call it 50. We'll round to 50. Which means that capital, remember, is 2L. So capital is 100. So the cost of producing 100 units is W times L plus R times K. So W, remember, is 50. L is 100. And the wage rate is 24. Rental rate is 8. So it's 50 times 24 plus 100 times 8, which is 2,000. Now let's continue with this example and see what happens as the prices of the inputs change. Let's suppose the price of labor drops. So the wage rate goes from 24, it drops down to 8. What happens now? The first thing that happens is that the ISO cost lines are not going to have the same slope anymore. They used to have the slope -3, but now they're going to have the slope -1. So we're going to redo our exercise. So what's the optimal way to produce 100 units? Well, we're going to set marginal rate of technical substitution. Remember, we calculated that to be minus 1.5 K over L. That's the slope of the isoquant. It doesn't depend on the prices, so that didn't change. We set that equal to -1, and then we solve for, we get the first equation now, instead of K equals 2L, is going to be K equals 2/3 of L. And we substitute that back into our production function. We substitute that back into 1.52 L to the 0.6, K to the 0.4 equals 100. Remember, that was the second equation. We substitute this thing in here, substitute that into here, and we're going to get this answer. I won't do this for you, but you'll have to take my word that if we substitute this thing into this and solve for L and K, we'll find that the answer is going to be L is 77 and K is 52. So what's the new cost of producing 100 units? Well, it's just going to be cost of labor, which is L times the new wage rate. So it's L times W prime plus K times rental rate. So it's going to be 77 times 8 plus 52 times 8, which is 1,032. Which is of course lower than the price of the cost of producing 100 units before the wage rate decreased. Which makes sense. The input got cheaper, so it's cheaper now to produce the output. One thing to note here that's important is that the firm substituted from capital to labor when labor got cheaper. Now, is this generally going to be true? Do firms typically use more of an input as it becomes cheaper? Yeah, because of the tangency rule. Remember, the tangency rule is going to tell us that the negative ratio of the input prices is equal to the negative ratio of the marginal products. Canceling out the minus signs, the ratio of the input prices is equal to the ratio of the marginal products. So if an input becomes relatively cheaper, you're going to use more of it. So in our example, the marginal product, the ratio of the marginal product is 1.5 times K over L. So when we're minimizing cost, we're going to set 1.5 K over L equals W over R. In other words, the capital labor ratio, this is something that people often talk about. Economists care about this ratio. So the capital labor ratio is always going to be W times 1 over 1.5 R. So as W decreases, capital over labor ratio decreases, which means that you're using more labor relative to capital when the wage rate decreases. So if you take the derivative of both sides with respect to W, so take the derivative of K over L with respect to the wage rate, we get 1 over 1.5 times R. What is R? It's the rental rate, which is a positive number. So 1 over 1.5 R is a positive number. So what this equation tells us is that how does capital over labor ratio respond to increases in the wage rate? Well, it's a positive number. So as the wage rate goes up, capital to labor ratio goes up. So if the wage rate gets more expensive, so if labor gets more expensive, then capital is going to be used more relative to labor. Conversely, if the wage rate decreases, then capital is going to be used less relative to labor. So if you hold R fixed, then increases in W are going to lead to increases in the capital labor ratio.